Hello, in this video we're going to talk about gases, the beginning of chapter 13 where we introduce what is a gas and how we measure pressure. So I'm guessing you've heard this before. Our traditional breakdown between a solid, a liquid, and a gas tells us that a gas has molecules that are moving around in space and will expand to fill whatever container the gas molecules are present in. This is in contrast to a liquid, which will kind of sit on the bottom of a container, or a solid, which has a definite shape. Now, many substances exist as gases by default, and so some elements exist as gases at 25 Celsius and 1 atmosphere of pressure, and they're the ones that are highlighted in blue in this table. And then some substances that are molecules are also found as gases. And this is, of course, not a definitive list, right? There's lots of molecules that are naturally found as gases. Just here are some examples. Okay, one of the most critical things we have to talk about regarding a gas is the pressure. So what is pressure? Pressure is defined as force per area. Now, force is a mass times acceleration, and so this ultimately arises from the incessant collisions of the gas molecules with the walls of the container. The gas molecules have a mass, they have some acceleration or deceleration as they jam into the side of the container, and this imparts a pressure on the walls of the container. And so that's where pressure comes from. The traditional way to measure pressure is by using an open mercury barometer of this type, where if this liquid is mercury down here, an inverted tube is placed into the mercury with a vacuum up at top. And so this might be new to you in this context, but vacuum means a place where there is no gas. Your vacuum cleaner at home is trying to approximate this by having a space inside the vacuum cleaner with a much reduced pressure. But in the context of science, vacuum means no gas molecules. And so, since there's no force from the top, because there's no gas molecules up here, the gas molecules down here will push on the surface of this liquid. And, well, that's going to push the liquid up the tube here, and it'll go up to some height. So the height here, if this is mercury, is 76 centimeters, or 760 millimeters, or about 30 inches. And so if you ever listen to a weather report and they talk about the barometric pressure of 29 point something, 30 point something, that is a measure of pressure that originally came from how far the atmospheric pressure would push mercury up a tube. You want to use mercury for this because mercury is very dense and it's a liquid, and so the height is manageable. 76 centimeters is, something you can have in your house. If you were to try to do this same thing with water, the height of the water column would be about 34 feet, which is kind of a pain to try to have indoors. Okay, we have many units that we use to describe pressure. The one we just talked about is centimeters or millimeters of mercury. And so that's this one down here, 760 millimeters or 76 centimeters. This is also called torr, after the inventor of this barometer. And so that's the unit we were talking about just a minute ago. The SI unit of pressure is the Pascal, which is again named after a scientist. And this is related to the SI unit of force, the Newton, and meters squared, which is area, which gets us back to our force per area, that is the definition of pressure. So you talk about pascals. A pascal is a really small amount of pressure relative to what we work with, and so you'll often have a kilopascal. And 100 kilopascal is equal to 1 bar, it's called, and a bar approximates the room pressure, the atmospheric pressure where you're sitting right now. A unit that more closely approximates that is the ATM, and this is a non-SI unit, and it's related to some number of bar. And so we use ATM a lot because chemists have a habit of using it, probably especially in America. And you can relate atmospheres to pascals thusly. Now, one you may be really familiar with is pounds per square inch, which is another measure of force per area. And 14.5 pounds per square inch is equal to a bar. Great, so we have lots of units for pressure. You'll need to know how to convert between pressure units. But don't worry, I will give you these conversion factors on a test, so you don't need to memorize the conversion factors, you just need to know how to use them. So what gives rise to the atmospheric pressure? So I mentioned this a minute ago, that the pressure at sea level is about 1 bar, about 1 atmosphere. Granted, the atmospheric pressure varies with the weather. A sunny day has a higher pressure slightly. But okay, say it's about 1 atmosphere. And so the origin of this fairly sizable pressure is that our atmosphere extends very high up from the surface of the Earth, say 10 miles or so. And all of this air sitting above you, well, the gravity of Earth pulls it closer to Earth, and it exerts a pressure on the air molecules below it, so on and so forth. And the weight of this column of air leads to the pressure on the air at sea level. Now, if you go higher into the sky, well, then there's less air above you, and so the pressure's less. And so this is why when you're flying in an airliner, you need to have the cabin pressurized, because the pressure outside is too low for you to safely breathe. So I mentioned the barometer, that's the traditional way of measuring pressure. The more modern way of measuring pressure is you use some sort of gauge. And ultimately you just buy it from the store and it tells you what the pressure is. And there's digital ones, there's non-digital ones. There's the silly ones you use to check your tire pressure. Things like that. That's typically how we measure pressure in the modern world. But we still use units based on how high does the column of mercury go. Okay, and that's our introduction to pressure and pressure units. And in the next video, we'll talk about calculations related to gas pressures, volumes, and temperatures. Stay tuned.